Okay, let's carry on. Hopefully you enjoyed the little interlude. We were talking about tween surfaces, which is the same as tween curves. So the question was, what if you wanted to actually have different behaviors across that original thing? So maybe things start off being like really tall, and then they kind of go down to being nothing in one corner. And the way to do that is by a command called tween surfaces. So what you do is you start with a surface. Let's just start with a surface here, and then you copy it and you do something to it. In this case, I could rotate it and maybe rotate it this way as well. And then you type tween surfaces, and tween is like between. So it makes a surface that's in between the first one and the last one. And so we're going to go from this one to this one. And you say, I want six surfaces in between, please. And then what it will do is create you this kind of gradual change between the two, which is, I find really, really cool. It's another really nice way of working. In the same way that tween curves, if I wanted 12 curves that went in between one and the other, I could do that using tween curves exactly the same way. Basically, everything I've shown you this morning is about saying, when you think about creating large amounts of complex geometry, the temptation is to do one of two things: either to give up because you think it's going to take hours and hours and hours, or to just do it manually and copy things over and over and over again. And actually, the answer is that there are usually tools that will allow you to create large amounts of quite complex geometry that follow rules that you have defined and you've set, without you having to do it manually and without you having to sort of feel like you would just give up. However, a lot of people reach for tools like Grasshopper, because Grasshopper sort of has this ability to create these kinds of things. My suggestion to you is, don't get into Grasshopper, because it will break your mind. And what happens is, and it's happened to me in my second year, so I'm just telling you, this is how to learn from my mistakes. I spent most of my second year staring at Grasshopper screens because I was like, wow, isn't it amazing that the computer can do this? But then I forgot to design anything. So don't do that. Spend time in Rhino, because your output is actually being made before your eyes. No one cares about the script that you wrote or the nodes that you connect. They care about your output. So focus on that. I want to show you, and then this is kind of going to be very much outside the realms of what you are going to be expected to do this year. But I want to sort of raise your eyes a little bit to what's possible with computers. This is a program called Houdini. I really love Houdini. Houdini is, it's incredibly complicated to learn. And it's the kind of thing I would suggest if you're really interested in like super digital parametric design and using like the cutting edge of what people are interested in. It's not going to be something where you go into practice and they go, oh, brilliant, you use Houdini, brilliant, that's exactly what we wanted. But if you understand the way that something like Houdini works, your digital brain is going to get stretched, and everything will be easy in comparison. So the way Houdini works is very different to the way that something like Rhino works. What you have when you're looking at Houdini is you've got your 3D viewport, exactly the same as with Rhino. But then you've got this thing here that says empty network, press tab to add nodes. And what you do when you're working with things like Houdini and indeed Grasshopper as well, is that you don't generate geometry by clicking on the screen. in 3D, you generate geometry by putting down things called nodes in a network. So I can press tab, and then I can put down a node called a geometry node. And this node, you'll see, has a little nubbin at the top and a little nubbin at the bottom. And what every node that you put down is going to have some kind of inputs and some kind of outputs. Some of them just sit on their own. So this geometry node is going to sit on its own, but there is no geometry that it's actually putting into the scene just yet. So in order to get it to output some geometry, what I have to do is go inside the node. It's like Inception. You go inside it, and you go inside it by double-clicking. So now I'm inside the geometry node. In fact, you'll see this obj geo1. So I'm inside my little breadcrumb trail here. And so it's basically now saying there's an empty network. There's nothing in here. So I could create some geometry. Well, one of the things I could do is I can right-click, or I can press tab. I could put down a sphere. So if I put down a sphere, then what happens is I get a sphere in my viewport. If I put down a grid, nothing happens. And that's because I can only look at one thing at a time, which seems like a bit of a limitation. So what I can do is come over to this guy here, and there's a little blue flag on the right-hand side of every node. I'm going to switch my blue flag, that's the visibility flag, to the grid, and now I'm looking at a grid on the floor. If I want to go back to seeing the sphere, I can go back to seeing the sphere. What's powerful about Houdini, and this is kind of why I've paired this with the previous examples of layering up your commands to make complex geometry, is that Houdini is really all about having nodes that feed into one another. So every node has an input and an output. You input some geometry into something, that node does something with that geometry, and then it creates a new output, and then you could do something with that output again. And then by the end, you might have a very, very long network of jobs that you've done that you've started with something very, very simple, and you've got something very, very complicated. So one of the things that we can do here is we can say, well, wouldn't it be great if we took that sphere and we made sure that there was points all over the sphere, like it was just kind of inundated with loads of flies, and they just like landed on the top of the sphere, and they just randomly, we had, 1,000 points randomly on the sphere. And we can do that using something called a scatter node. And I put down the scatter node, and the first thing that it's going to say is, I need some input. And scatter node only knows what to do when you feed it some geometry. So it's like, I'm hungry, give me some geometry, please. And we just generated some geometry. We've generated a sphere. So what I can do is I can drag this little circle here. I can drag that to here, and it will draw a string in between the two. And now geometry is going to flow down that string, feed into a node called the scatter node. And then I'm going to switch the visibility of scatter on. And what you'll see is I've now got a whole load of points scattered all over the surface of the sphere. The cool thing about this is, let's say I want to change my mind about what starting point I use. So instead of a sphere, I want to use something else. Like Houdini has a whole load of really useful test geometry. And one of them is like this thing called a rubber toy. So they've got this lovely like rubber toy, and we go, oh, great, lovely. Well, wouldn't it be cool to do that same thing with a rubber toy? Well, yeah, you can. All we're going to do is we're going to move that string to not be connected to the sphere. We're going to connect it to the rubber toy instead. And now we end up with points scattered all over that instead. So effectively what we're doing is a bit like the record history thing. It remembers the starting point and then what you did with it. But this just visualizes it very differently. So it says, effectively, you're creating a recipe. It's like a recipe book that says, start with this thing, then do that, then do this, then put it in the oven for 30 minutes. And then at the end of it, you've got your meal. And literally, it's going to go like down the list like this. There are a few really cool things in Houdini. One of the things that Houdini does a lot is right down the bottom, you'll see this timeline. And it's a timeline which is for animation. So at the moment, I've got an animated timeline between 1 all the way up to 240. So I've got 240 frames of animation to play with. Now, I probably don't need all 240. I'm going to move that down to 120. There we go. So I've only got 120 frames to play with now. And you'll see it only goes to 120. I can just change that using this thing here. But basically, I'm doing that so that my computer can actually keep up with what I'm doing. I'm going to save this while I can onto desktop. We'll call this width 01. Make sure you save a lot because Houdini does crash all the time. So just if you are using these kinds of more involved complex geometry generators, then they will just crash your computer very, very easily. One of the cool things we can do, and this is kind of why it's really nice to play, is Houdini has a whole plugin called Pyro, which is basically for blowing things up. So if you've ever wondered, like, oh, wouldn't it be cool to have a building and you just blow it up in a computer? Turns out you can. So what I'm going to do is I'm going to do Pyro configure billowy smoke. And what this does is actually, I don't need to spend a lot of time. It'll just put down a whole load of nodes which are already configured to make this kind of smoke simulation. I don't have to do anything. It'll just come ready to go. And you'll see here, this is more than just one node. This is now actually a whole network. So the way this works is it starts with a torus or a shape, and then it turns that into a source of pyro, which is like fire. And then it basically sets some things like it sets the speed of that smoke. So which way is it going to be blowing? What's going to be happening? And then it does some other things. And then there's a pyro solver. And a solver basically then just says, every step of the animation, I need to work out, well, if I know the smoke was there in the last frame, and then there's some kind of force acting on it, where is it going to be in the next frame? And that solver does that calculation for you to work out what the next frame is going to be. And then this output is just basically just a thing that sort of captures that output. And then what I can do is I can press play. I'll actually push this little button here. I'll press play, and then we'll watch what happens. And that took what, a couple of clicks, and now I've got some really interesting exploding smoke, or like a sort of a smoke source, like a fire source. And you can see why this is used in visual effects, right? Like, why architecture though? Well, the thing is, I find a lot of these kind of physical simulations really, really interesting. And one of the things that you can do is we could start with, let's start with our toy here. What I'm going to do is I'm just going to move him up a little bit, up into the sky. I can do that using this guy here. Woo! Up he goes, just translating him up. So there he is. He's sitting kind of up in the sky. And then what I'm going to do is if I just now, basically, I'm only ever looking at either that geometry. If I press play, nothing happens. He's just there. He's stuck forever. Nothing's happening to him. But what if I told the computer that this thing is actually made of some kind of physical material that actually obeys the laws of physics? Like maybe if this thing was like a balloon. Well, if I type balloon, I've got a thing called velum configure balloon. And what you can do is you can put in, there's a little red thing saying required geometry. Give me geometry, please. I'm going to put this in. And then what this is doing is it's saying this thing is now made of cloth. And cloth is just a very simple set of maths. It just says, how stretchy is this thing and how much does it bend? So I could change some of those things. We might come back and change some of those values. And then there's this thing called velum pressure. And what pressure does is it says each point on this surface, I want to kind of like push away from all the other points, like you're blowing up a balloon. So this thing is now going to act like a balloon, except it isn't going to act like a balloon until nothing's happening. Nothing's happening at all. It isn't going to act like a balloon until I put down a vellum solver in this case. There we go. And that's going to require these two inputs. And then what I'm going to do is I'm going to come in here just quickly. Oh, it's taking a little while. Yeah, here we go. Yeah. So the first thing that's going to happen now is if I press play, what happens? Well, now we've told it that this cloth has weight, and the solver knows what to do with things that have weight. They fall down, right? Fall towards the center of the earth. But that's pretty boring because all that's really happening now, it's doing something quite nice. It's kind of like flapping around a little bit. Do you see? Oh dear, he's looking a little bit worse for wear, a bit sadder than he was before. But the thing is, wouldn't it be useful if that thing didn't just keep falling forever, but actually had a ground plane? Ooh. So let's do, here we go, ground position. I'm going to put the ground position in, and what that will do is put this kind of imaginary plane and say, don't fall through the ground. The ground is solid. So now what we're going to do is we're going to click play, and we'll go, squish. And clearly, this guy here is not a very well blown up balloon. Doesn't have quite enough puff inside him. This bit here is doing quite well. Like, that's still full of air. But now it's worked out, that simulation. I've basically got this kind of physical world inside the computer that I can start to do things with. Is this fun? Are you kind of going, I don't know whether it's going to be architecture yet, but, it's kind of fun to play with. Rhino can't do this. Rhino just deals with the geometry, and you put the geometry in space, and that's it. This allows you to actually act on it and have physics acting on it. Let's just try something here, because what I want to do is I want to imagine that this kind of weird balloony thing is now being acted upon by the pyro smoke simulation that I had before. So I've got a smoke simulation here. It starts off as this thing, and it kind of then billows out. And in fact, what I might want to do is just move that down a little bit. There we go. So it's like underneath the ground, and we'll do the same thing there. So that starts underneath where my little rubber toy thing is going to be. And then that smoke is kind of going to billow out. And would it be nice if that smoke then kind of catches this balloon animal thing and then kind of blows it around like the wind? Well, we can absolutely do that. So what we do is we put down something called a particle operator network, a POP network, particle operator. And what I want to do is I want to say wherever the smoke is blowing, then I want to operate on the points that make up that cloth simulation. So I have a POP network here, and I'm going to connect up the output from the vellum solver here. And I think that's right. Let's find out. And then I want to also connect up the billowy smoke output. I come in here, and the first thing that you'll see is the two aren't really doing much between themselves. They're not really interacting at all. But what I want to do is I'm going to do an advect by volumes, POP advect by volumes. The smoke is actually what's called a volume. It's got a whole load of voxel values in it that sort of show you which way the smoke is blowing. And it's going to ask me, well, which volume you want me to advect by? And I'm going to say the second context geometry, basically the second input into that node. And this is now going to take a little moment to think. Here we are. And if I'm right, no. Let's try all points. There we go. Oh, way! Well, that's fun. Let's try all geometry instead. There we go. Oh, whoa. Now, this is why it crashes your computer. Because if you get the wrong setting, it just goes mad. Pop source first input. Emission type. I think I've used the wrong thing here. I don't think I want a popnet. I think I want a dopnet. Yeah, I got it wrong. Here we go. You know, we went inside the geometry node. We can go inside the vellum solver and we can add an extra thing in here, which is going to be, at the moment, all it's doing is it's saying work out based on your own geometry. But what I can do is I can do a pop add vect by volumes, same as I was using before. And then I'm going to wire that into the force node. And instead of wiring that in, what I can do is I can add that to the third context. And then this then says, listen to the third input and then work out the velocity of the smoke, the speed of the smoke and where it's wanting to go. And then, whoa-hey! The smoke is going to blow my weird balloon animal into the sky. And then as soon as it kind of leaves that area, it's just kind of going to fall down onto the ground. And then it's going to hit the ground and sort of crumple. And what I've done is I've not just made a world of geometry, I've made a world of physics, where all of these things kind of combine and have conversations with one another. It's taking a little while. Oh, there we go. Let's just watch that a few times. So now I'm blowing around that little sort of balloon toy with the smoke that I've made. Fun? Now, the cool thing is, once you've done that, let's say you then change your mind about what the geometry is that you wanted to start with. I'm just going to sort of put this on so that you can just... let's just try that. There we go. Oh, no, can't really see it. Let's not worry. Let's change our mind, and instead of the rubber toy, maybe we'll use the head of a pig instead. And if I do this, I start with the head of a pig. Pop him up into the sky a little bit. There we go. And I don't have to change anything in the recipe that I've got going on. All I'm going to do is I'm going to run the same thing again. And now the head of the pig is going to be blown around like a balloon. And I can also come back and change my mind about all sorts of settings about where these things are going to be going. There we go. Like, for example, the cloth. Maybe I want to increase the pressure. The pressure kind of pushing this thing out. And the way I can do that is that the rest length scale, you'll see if I turn this on, basically what it's doing is it's drawing lines in between all the points that make up this geometry. And then it's saying, try and keep those lines the same length. So the whole thing kind of feels like it's not going to collapse in on itself. But what we can do is we can say, I want that rest length scale to be, try and make all those lines twice as big. And then with the cloth, what we can do is we can say the stiffness, let's just turn the stiffness down a little bit. There we go. And then also let's try and make sure that it doesn't bend as much. So I'm going to turn up the bending. Turn down the ability for the cloth to bend. So it kind of ends up like more heavy material. So it doesn't kind of collapse in on itself as much. And then let's try and see what happens. And I'm not having to rebuild anything. There we go. The first thing that happens, this is starting to stretch the rules of physics a little bit too much. The first thing that happens, I don't know if you can see that, the first frame is that the pig kind of like expands out like it's been blown up like a balloon. And that's because I increased the rest length of the pressure setting. So it's now just trying to be like a really blobby balloon, but then it starts being affected by that smoke. And there's this point at which the effects of the smoke and the effects of all the settings that I've done, they're all just a bit too much. And it starts to kind of break the geometry. So potentially we just need to turn that down a little bit. Potentially it's that bending force. There we go. Fun, right? Last thing is that one thing that is quite useful is then being able to say, well, what could I generate with this? What's possible to generate with this? One of the things that you can do is I'll put down a point operator network here. I'm going to ignore the pig head for a second and just come into this popnet. And I want to let's start with this, and then volume points from volume. That's what I want. I want to basically fill this pig's head with points. And I want to send those points into my point operator network. And I also want to bring in, there we go. So basically there's my pig head, just kind of full of points. So I've got some starting points to start with. And then I want pop add vect by volumes. I'll bring it in here. Boop. And then I want the second context geometry. And I want to do this onto all points. And so now what I have is this. Basically, I'm using the pig head to kind of emit these points into the sky. And they're going to get blown around by this smoke. One of the things that you can, though, do is... I was thinking... Obviously, you've got bad internet connection. Come on. You can do it. I believe in you. Yeah, there we go. One of the things that would be really interesting, though, is as those particles travel in the smoke and in the wind, what we could do is we could draw a line wherever they go, and we could turn that into some geometry. So I'm going to say for every frame that's less than 2, I want the birth rate to be 1. So every point that I start with, I'm going to emit 1 point into the world. And then that point, I want that to blow around according to the smoke. And then I want to see what I get from there. There it is. So I end up with this kind of initial set of points, and then they get blown by the smoke into the air. And you're like, oh, that's kind of cool. I kind of like that. But architecture is static. It isn't animated. So how can I turn something from this animation into something that is geometry that I can use in a kind of more static way? Well, the way we can do it is we can use something called a trail node, and we feed these point geometries into a trail node. Whoop, there we go. And we've got 120 frames. We've got 120 frames in our animation. So I'm going to set the trail length to 120. And so what this will do is it will draw a line made up of all of the points that it's animated by, which is pretty cool. And then I can say connect these together, and I'll untick close rows. And then I end up with strings going into the sky following the action of that smoke. And I play a lot with this kind of way of working. One of the things that we can do is we can then change our mind a little bit, maybe about how turbulent this is. So I'm going to turn the turbulence up, and I'm going to make the swirl size a little bit less. I'm going to come back to the beginning here, and then what you'll see, hopefully, let's turn that all the way up. We're starting to get a little bit more turbulence there. Maybe I'll turn that all the way up to something a lot bigger. Just see what happens. Yeah, there we go. So now these lines are not just driven by the sort of single force of the explosion. There's a kind of a turbulent airflow going on in there. And one of the things that would be nice maybe is also to color those lines based on how fast they're going. So I'm going to say remap attribute, and that attribute is going to be the velocity. We compute the range, and now what I've got is lines that are going fast are one color, lines that are going slow are the other. And now I can watch that. Pretty fun. And you can imagine that this actually could become quite sculptural. So here are some examples from other work from a while back now. This is the same, except the lines are just kind of constrained to be straight lines rather than curvy lines. This is much more curvy. But obviously these lines are basically, they're driven by exactly the same thing. What I've got is I've got an ability to have a simulation of some physical environment, and then I'm outputting geometry based on those processes. I will see if I can find, there was a really nice image somewhere recently. Don't know where it went. No, who knows? It will turn up somewhere. Oh yeah, here we go. This is the same. So this is these lines are basically the result of that kind of turbulent airflow, and it's basically just saying if you ran the animation, that would be the path that a particle would take. Let's turn it into something physical that we can actually do something with, and then you can move into other software to render it and that kind of thing. I just wanted to show you that like there's kind of no end to what you can do with a computer. We've got 5 minutes for questions, and then I'll try and be around for sort of 10 minutes at the end if you've got specific questions about things like modeling task and stuff. Any questions on what we've seen today so far? Yeah.
So what exactly do you use this like software for?
Well, the the majority of these kinds of explorations are really about very early stage conceptual design. For me, well, so my background before I was an architect was in physics. And so often I find myself thinking, is there a physical process that has some output that I find quite sort of aesthetically beautiful, that I think, oh, wouldn't it be great if architecture captured something of that? Now, theoretically, there is quite a lot of there's a lot of precedent for that. So, like a lot of classical architecture is based on things that you find in nature. Like there's a kind of like conversation about the natural world, and then when we build buildings, we're kind of like mirroring that natural world. So for me, I find myself thinking quite a lot about if there's a way that some things like structural forces. Structural forces don't tend to be expressed very elegantly in buildings. So let's just take this room as an example. How is the roof kept up right now? Well, the roof is kept up by these massive columns, which basically mean that half the people in the room can't see the screen, and I can't see the other half of the people. Like, it's not an elegant solution. Whereas if what I could build is some kind of simulation, and this happens a lot, I will find ETH Zurich thin concrete. This is like this ultra thin concrete roof. The reason they can make this concrete roof so thin is because of the mathematical simulation of those structures and the way that those forces are. They know it's going to behave in the real world because they modeled it in a computer first. So for me, I think of a lot of that as a kind of, this is my testing ground before I have to build something. For other people, it's very different. For other people, let's think. I think of someone like Barry Walk, who used to teach here actually, and he was my tutor. He is much more interested in this question of like hosting growth. So he thinks of things of like, well, can moss grow in that little crack? Or whatever, and then he would probably use. I think he does use Houdini actually quite a lot, but he would write a script that isn't thinking about movement or forces, but he's thinking about, is that space something that gets water and sunlight so that something could grow in it, and then you can simulate that, and basically you're kind of trying things out in a computer before you then go and build it in real life. So that's how I see it, but also it's like a different way of almost sketching. Sometimes you can test out a thought and think, oh, is there a way of kind of trying this in a computer? For me, there was one other thing, which was a long time ago now. I don't think I actually have lots of examples here, but oh yeah, this is a nice project, which is all about flow of rainwater down a surface. So the whole project was literally just based on this idea of, if a water droplet falls on the ground, like which way does it go? Like where does the river runs? Where do the rivers run? And I ended up using a computer algorithm that I built myself, but Houdini can do it, Rhino can do it, Grasshopper can do it, where you say, tell me what those lines are. And I can't draw those lines using a pen and paper, but my computer can do it for me. And then I can draw over the top of it architecture that responds to that. So there are plenty of answers. Probably for you, there might be something very different that you're interested in. And the challenge for you then is to say, how can I get a computer to do some of the hard work or translate that question into a computer style problem that means that your output is elevated because of it, not distracted because of it. It's quite a highfalutin answer, but does that help? Yeah, yeah. This I don't know whether I've got time to show you. Let's just try it. here's my guy. I'm going to export him. I'm going to export him as a OBJ, I think. Yeah, there we go. I'm going to put him on my desktop. Guy. And then maybe reload geometry. I think maybe the scale's all wrong. Where did my guy go? Probably have to move him to the center of the file, and probably also have to scale him down so he's very, very small. Because Houdini and Rhino, they have different scales. So let's try that one more time. Polygon mesh curves, formatting, maybe. Let's try it, see what happens. Load all geometry. Where is he? Come back. Anyway, what is possible to do is you take some geometry from Rhino, you export it as an OBJ, and then instead of my pig's head being blown around, it's your building being blown around. You know, it's possible to do. For some reason, it isn't working for my little man. That's in theory you can do it. I've done it before where you take your thing and then you can explode a wall so that it crumbles. And you sort of split it into lots and lots of little bits and it kind of falls onto the ground. If we look at one like this, rather than treating it like cloth, we could do something called an RBD. Bullet solver. And then we need an RBD exploded view fracture. Where's fracture? RBD material fracture. There we go. So here we go. And that goes into there. Constraint geometry. Let's put that in there as well. Bring my view back to here. Again, I will have to put a ground plane somewhere. Strengths. I'm going to put my ground plane. Properties. Ground plane. There we go. So there's my little dude. And he starts here and then he kind of falls and some bits of him fall off. I think we could do better. There we go. Completely falls apart. So you could imagine doing that to your building. You know, imagine what your building is like in 1,000 years. You know, it's fun. Any other questions? Have you got a challenge to go away and model something well and push yourself the next question? I'll stick around for a couple of minutes, and I think next week is basically a kind of like more of a Q&A. So come with your questions, things you're struggling with, anything specific that you want me to show you that's specific to your projects, and we will go from there. And I think you don't have lectures with me in weeks 10 and 11, or 11 and 12. It's in the module handbook, but we're coming towards the end of the modeling thing, and now we're thinking more about getting ready for exporting stuff and actually making stuff in real life, which is a bit more fun. Cool. I will stop the recording.